Let's consider a curve x to the 2/3 plus y to the 2/3 equals 4. We want to find the arc length of this curve over the interval x greater or equal to 1 and less than or equal to 8. Recall that when y is equal to f of x and the interval is x greater or equal to a less than or equal to b, the arc length is given by the formula integral from a to b of the square root of 1 plus f prime of x squared dx. Now we can also write this as the integral from a to b of the square root of 1 plus y prime squared dx. So let's solve for y prime. We can solve explicitly for y as a function of x, or we can use implicit differentiation. Implicit differentiation is a little bit easier, so let's go with that. Sometimes that's helpful. So the derivative on the left hand side is 2/3 times x to the minus 1/3 plus 2/3 y to the minus 1/3 times y prime equals 0. Let's solve this for y prime. First we'll multiply everything by 3/2 to get rid of the constant. So on the left that gives us x to the minus 1/3 power plus y to the minus 1/3 power times y prime equals 0. So y to the minus 1/3 times y prime equals minus x to the minus 1/3, and that's the same as minus 1 divided by x to the 1/3 power. Let's multiply both sides by y to the 1/3. Y to the 1/3 times y to the minus 1/3 on the left is 1, so that just leaves us with y prime, and that's equal to minus y raised to the 1/3 divided by x to the 1/3. Next we're going to square y prime. So y prime squared, which is what we need for the formula, is equal to y to the 2/3 divided by x to the 2/3. Now at this point this is not a good thing because we need to eliminate y and just have a function of x on the right hand side, but adding 1 to y prime squared is going to accomplish exactly that. So 1 plus y prime squared is equal to 1 plus y to the 2/3 divided by x to the 2/3, and the common denominator is x to the 2/3, so this is x to the 2/3 plus y to the 2/3 divided by x to the 2/3. But recall that x to the 2/3 plus y to the 2/3 equals to 4 the way our equation was defined. So this is equal to 4 divided by x to the 2/3, which is just a function of x. And now we can proceed with computing the arc length. The arc length here, since we're working on the interval from 1 to 8, is the integral from 1 to 8 of the square root of 4 divided by x to the 2/3. And this simplifies to the integral from 1 to 8. Square root of 4 is 2, and square root of x to the 2/3 is x to the 1/3. So it turns out to be quite a simple integral. So we have 2 times integral from 1 to 8 x to the minus 1/3 power, and this is equal to 2 times x to the 2/3 divided by 2/3 evaluated from 1 to 8. Now we can simplify this even more. 2/3 in the denominator is 3/2, so this is 2 times 3 over 2 times x to the 2/3 evaluated from 1 to 8, which is 3 times x to the 2/3 evaluated from 1 to 8. Plugging in 8, cube root of 8 is 2. 2 squared is 4 times 3, that's 12. Plugging in 1, we just have 3. 12 minus 3 equals 9, which gives us the final answer. The arc length of this curve over the interval 1 to 8 is equal to 9. For more videos, visit www.mathprepvideos.com. www.arclength.com.